Hello my dear students, I am B S PANDEY, your physics lecturer. In series of standard 12 video lecture, my dear students, we have reached to the lecture number 78, and presently we are studying alternating current. It is the chapter number 7 of NCERT. Okay my dear students, today we will study the combined devices L, C and R, that is the LCR series circuit. We will study about the power factor also, that is which quantity or the factor define the power of LCR series circuit or any circuit under AC supply. Okay students, so let's start today's lecture. It is lecture number 78. Here we are in chapter number 7 of NCERT, alternating current, that is AC. Okay, my dear students, till now we have studied individually all the circuits. It is the AC supplied across resistor, inductor and capacitor one by one. We have studied the phasor diagram as well. Today we are going to find the combined effect of L, C and R, that is LCR series circuit. This is very important, my dear student. LCR series circuit. Here inductor, capacitor and resistors are connected under given load, under given AC supply. It is E0 sine omega t. The inductance, it is L, capacitance C and resistance, it is R. At any instant the current, it is flowing, suppose I t. What we are having? We have the E t as E0 sine omega t. This is our given value. Here L is the inductance of inductor, C is the capacitance of capacitor and R is the resistance of resistor. Okay my dear students, if we will try to compare or try to focus over individual L, C and R, what we will get for this L, if this is the current I, then E rotates with the omega t. Here E t. Okay, it is rotating how much? It is rotating omega t current, sorry, the voltage. But we know that for inductor, if E is E0 sine omega t, current we obtain, I hope you remember which one lead and which one lag. In inductor, voltage leads and current lag. It means the equation of current for inductor, it will be the I0 sine omega t minus pi by 2. Is it okay my dear students? Yes, it means the current will move omega t minus pi by 2, looks like this one. This is I t. Alright, but this is the angle how much? Pi by 2. Now look at here for the capacitor. In case of capacitor, my dear student, we will rotate Et for the omega t again. But we know that the equation for the current here in case of capacitor, it is It is I0 sine omega t plus pi by 2. Here current leads by pi by 2. It means the current will rotate pi by 2 more than the voltage, and this is nothing but the pi by 2, as this is the pi by 2. Remember. Alright. In case of resistor, I hope you remember, if E is E naught sin omega t, then we got I as IT as I naught sin omega t, and phase difference of resistive circuit is 0. So we have, if this is ET rotated by phi, alright, then I also rotate for the same, that is omega t. Sorry, this is omega t, this is omega t. Okay, my dear students. Now, if we'll combine all the three phasor, alright, if we'll combine all the three phasor, then how this three phasor looks like. Before combining this three phasor, remember, current is constant in each device. Here the current is I, here the current is IT, and here the current is I. We know that the current remain same in series. So if the current we take over the one axis, suppose along the x-axis we are representing the current. I hope it would be very easy to understand for you. If we take this current on the x-axis, it becomes the phasor of LCR. How it looks like? Suppose this is the current IT. Okay. If you rotate the current along the x-axis, it means you are rotating by omega t. But in case of here the voltage across the resistor, what will happen? It will move with the current. It means the voltage of resistor, it will be here, and we can write the ER. Okay. Now look at here. To make this current along the x-axis, how much you have to rotate? If you will rotate omega t, if you will rotate this I omega t, then it will be along the y-axis. Listen carefully, my dear students. Try to understand. If you will rotate this I by omega t, it will be parallel to the y-axis. Why? If you are rotating this as omega t, of course it is also rotating omega t, and it becomes along the x-axis, and this becomes along the y-axis. Why? Because angle between I and E is 90 degree. Now we are having the current along the y-axis. Further we are rotating this current to make over the x-axis. It means this E will be here, E already along the x-axis by rotating omega t. So thus E will be along the negative of y-axis. Okay. So E by capacitor EC will be along this one if current rotated along this one. I hope you understand. Now for this one, you have to rotate this current in this way. This is the current, you have to rotate in this way. So the current will goes in this direction and the voltage will be in upward direction. So we will write here EL in this direction and the current goes in this direction. This is the final phasor diagram of LCR series circuit. Now we will study one by one the case. Okay, my dear students. But we can write the net voltage over here, net voltage, that is the net EMF, we can write here as E net is equals to ER I plus EL minus EC J cap. Yes, could you write, my dear students? Yes, we can write. If it is a vector representation, we can write ER and this one. Alright, now We know that E net is I times, suppose if the peak current we are considering, I times Z, that is the net resistance of the circuit. Here the Z is equals to root under ER square plus EL minus EC whole square. What is this Z, my dear student? So Z is nothing but the net resistance of LCR circuit. Okay, and its unit will be same as the resistance, that is ohm. My dear students, further we can write this equation as, we are going to find the equation of impedance. This Z is called the impedance also. We have studied already. Z is called the impedance, that is the net resistance, and this will be the I naught R square. Could we write here the ER, voltage across resistor, can be written as the current into resistance, plus I naught XL minus XC whole square. Yes, could you write? Now, here I naught square and here I naught square are common, will be taken out. So, we will have the equation. Let me write this one, my dear student. This is not very tough. It's the very simple, my dear student. I naught Z is equals to, I naught will be taken out, root under R square plus XL minus XC whole square. Yes, could you write? I naught will be cancelled out, so the impedance is nothing but root under R square plus XL minus XC whole square. This one. Okay, my dear students? Yes, this is the impedance. Impedance of the circuit. Which circuit? LCR series circuit. This is the impedance. Now, we obtain the net voltage as, for the different cases. Case 1, suppose if voltage across inductor is greater than voltage across capacitor, then the phasor diagram looks like this one. This is the I, and EL minus EC, look at here, EL minus EC will be positive. If EL is greater than EC, then this will be the positive, and the net voltage will be in upward direction, EL minus EC, and the resultant voltage can be written as, because there is no change in ER. Remember, ER is over the same axis, and this will be the net voltage. Okay, my dear student, this is the net voltage, and this could be the angle between current and net voltage, called the phase angle. So we can write the Z is similar as this one, but the phase difference we can write, that is the phi, as tan phi is equals to tan phi. We can write here y by x. This is the y and this is the x. This is the y and this is the x. EL minus EC divided by ER. Okay, and also we can write here the phi as tan inverse EL is nothing but the XL minus XC divided by R. How it becomes this equation? So Here the current we can write the IXL minus IXC divided by IR. I will be cancelled out. So XL minus XC divided by R, that is the resistance, and this is the phase difference between the current and net voltage of LCR series circuit. Okay. Now we will study one more concept after knowing the case if both the voltage become same. If both the voltage become same, then we will study what will happen. Okay, my dear student. If voltage across both the device, that is inductor and capacitor, will be equal, then try to analyze the case. This one will be the case here. If EL equals to EC. Okay, this is our case. Then E net will be how much? Here ER I cap plus EL minus EC J cap. It was, this quantity will be how much? 0. This will be the 0. If both are same, then this will be the 0 and the net voltage will be ER only. What does it mean? Try to recall, my dear students. We study the capacitive circuit gives the 0 power. Inductive circuit gives the 0 power as well. But there was no 0 power for the resistive circuit. You can see here the net voltage is only for the resistor. It means the net voltage, it is dropped across the resistor we are getting as a output. Alright. Otherwise the rest two are cancel out. Here, this particular case of LCR series circuit, my dear students, is considered as the resonance condition. Okay, this is called resonance condition. Resonance condition. Remember, if it is the resonance condition, it means the AC is fluctuating or moving with certain frequency, and that frequency will be the constant, and that constant frequency we can write here. Look at here. If EL equals EC, it means I naught XL equals I naught XC. Am I right? Yes. I naught cancel out. It means L omega equals to 1 by C omega. And one thing which is important, look at here. This omega square can be written as 1 by LC. With which frequency now, with which frequency AC will oscillate in this circuit LCR in this condition, that is the resonance condition. So we can write omega as 1 by root under LC, and this is the resonance frequency. Could you find the linear frequency also, my dear students? Yes, because this could be written as the 2 pi f. So the linear frequency f will be 1 by 2 pi root under LC. Okay, so this will be the linear frequency. Now it is very interesting. If voltage across inductor and capacitor becomes 0, it means the power of the circuit will be maximum. Alright, power of circuit will be maximum and the current will be also maximum. How? So look at here. Try to understand this concept, what I am telling you. Actually, this one is the very, very important, and this particular topic will lead you to the resonance condition and sharpness of this resonance condition. With the help of diagram, we will study. The student, look at here. This is the particular frequency at which we are getting maximum current. Am I right? Yes. How? It was IZ is equals to E net. Okay. It means I is equals to E net divided by Z. And what is Z? So it is E net divided by root under R square plus XL minus XC whole square. So if you are providing some voltage, net voltage across the resistor, and there is a voltage drop across this value, okay, voltage drop across this value, if there is no value of XL minus XC, what will happen? This quantity will be smaller. If it is smaller, I mean it is 0, alright. So this quantity will be smaller. If it is 0, then this quantity will be smaller. And if this quantity is smaller, then I will be larger. And the smallest value of this quantity will be only the R, nothing else. Why? If it is 0, because we cannot change the voltage across the resistor, we are changing the voltage across either capacitor or inductor, and we have maintained the voltage across these two such that it becomes 0. So in resonance condition, we can write, my dear student, this Z is minimum. Alright, Z will be how much? It is minimum, and current will be maximum. Current will be maximum, and the very important power will be also maximum. Okay, power will be maximum in this condition. Now, for this resonance condition, when current is maximum, at which frequency it is maximum? So that frequency, suppose we are representing by F naught, it is how much? 1 by 2 pi root under LC. You should remember this equation and this condition. Okay, if we are representing omega naught, so this will be 1 by root under LC, and this is the frequency at which the current is maximum. Now my question, if we will increase the value of frequency omega further or decrease the value of omega, then what will happen? Whether the current will increase or decrease? It is quite obvious. If it is the maximum value, so for any value of omega except this 1 by root under LC, the current will change. How this current will change, we can analyze using this equation. Okay, so let us analyze this particular equation and try to plot the graph. But before that, you should remember, my dear student, here we obtain the equation for the LCR series circuit. What was that? Actually, the net voltage E naught sine omega t, and this voltage dropped across inductor and capacitor. Am I right? That is minus L di by dt minus Q by C minus IR. It was equals to 0. If you are thinking from where Sir has written this equation, so try to recall, in series circuit we have three things, that is the L, C and R. It means the total voltage dropped across these three devices only. Alright, so we can write this equation. What we are having the input EMF for this particular equation. So the input EMF, we are having the ET as E naught sine omega t. Remember. Now what we got the current as output from this equation by applying this EMF. So we got the IT as I naught sine omega t, but we know that the current and voltage having some phase difference as well. Okay, if EL is greater than EC or EC is greater than EL, in that case current and voltage has some phase difference. Let that phase difference as phi. So we can write sine omega t plus or minus whatever may be the phi we will get. Okay. Now these two are very important. You have to keep in your mind, my dear students. Here the phi we can calculate. What we are having the net voltage, try to recall the net voltage we are having EL minus EC J cap plus ER I cap. This was the equation we have. So the tan phi we can write, tan phi, how much we can write? The tan phi can be written as with the x-axis, then ER will be down, ER and EL minus EC. Even I have discussed about the phi earlier, and that was the phi here we are considering. Again we can write. Alright, so this is the phase angle, that is the phase difference between current and voltage. So finally we have two input and output as the current and voltage. Remember, for LCR series circuit, the voltage supply E0 sin omega t, then current will be I0 sin omega t plus phi. If current you are representing by I0 sin omega t, then you have to represent E as E0 sin omega t plus phi. What will be the phi plus or minus? It totally depends whether EL dominating or EC dominating. If EL greater than EC, then using the equation you can write this phi will be the positive. If EC is greater than EL, then phi will be negative. Okay, my dear students. Now we were about to study the analytical relation between this omega and current, that we are going to represent here using a graph. Okay, my dear students. So let me start plotting a graph of voltage, this frequency and net current. Okay, look at here. What we are having? We are having I is equals to E by Z. Alright, yes, we have this equation. We can write as E by E net, E by root under R square plus L omega minus 1 by C omega whole square. Okay. Now my dear students, if we are increasing, if this omega is for maximum current, I maximum, we know that the resonance frequency we are having omega naught as 1 by root under LC, this one. Okay, but when we are increasing, omega is greater than omega naught. If omega increasing, it means it is increasing. If omega is greater than omega naught. So look at here. As this omega will be greater, omega will increase. In this equation, look at carefully. If omega is increasing, if this omega is increasing, this whole quantity will decrease and this will be increased, and this resulting will be increased. Am I right? Yes, this will be increased. If it is increased, it means this whole quantity will increase. Am I right? And if this Z is increasing, it means I will decrease. Due to this one, Z will increase and I will decrease. Okay. Now, if we decrease this value, that is the omega is less than omega naught, then what will happen? So here, as this omega is decreasing now, if omega is less than omega naught, any frequency less than resonance frequency, then what will happen? What we are doing actually? We are decreasing this omega. So look at here again carefully, my dear students. As this omega is decreasing, if this omega will decrease, what will happen? This quantity will decrease. Alright. Now, if this omega is decreasing, this quantity will increase. This quantity is increasing and this quantity decreasing. It means equivalently you will get a negative value but higher value. Okay. This will be the higher value but in negative. But here the square will make that value as positive. Alright. So this value is increasing but negatively. But a square make that will positive. It means again this is increasing. Due to decrease in omega, again this term is increasing and resultant value, that is the Z, will increase. Alright. Again this Z is increasing. And if this Z is increasing, of course the current will decrease. So in each case, my dear student, whether the omega is greater than omega naught, that is the resonant frequency, or omega is less than omega naught, that is resonant frequency, in both cases current is decreasing. And hence we can conclude that we will have the maximum current for the resonant frequency. Question may be asked in this way also, that you have to prove. Okay. Now, my dear student, remember, once you will be conceptually sound, then any question will be asked in board or anyone will ask to you any type of question, you will be in position to explain in better way. Okay. So try to pick the concepts. Now, my dear students, we are going to draw here the graph of omega. We can draw the graph of Z and omega also, but we are going to draw here the graph of Z and omega. Okay. Or we can put we can draw the graph for both the quantities. Graph of omega versus current. Alright, the first graph. We will draw both the graph. On this y-axis we are taking the current. Alright, and on this axis we are taking the omega. My dear students, suppose this is the omega. We have not chosen this as origin. Okay, let me wrap this one. Suppose this is the omega naught. Okay, and we are having the current as maximum value. This one, current as maximum value. This one is the current. Now, if we will increase the omega, that is after the omega naught, what will happen? The current will decrease, and if we will decrease the omega, again the current will decrease. And using that equation of current and voltage, if it is the constant, then it looks like the equation of this one. The current is decreasing but slowly it is increasing, and it looks like this one. Okay. Before this omega also you will have the graph in this way. Okay. Here of course you are decreasing, but what will happen, as decreasing and increasing the value, this value, you can think upon the saturation state, the current, alright, the current will saturate somewhere, so you can think upon the saturation state. But this is the graph. If you will draw the graph of, second graph of Z versus omega. Okay. Could you plot the graph of Z versus omega, my dear students? Try to plot the graph of Z versus omega by yourself. Okay, my dear students. So today we have concluded the whole concept of LCR series circuit. next lecture, my dear students, I will solve few questions to just feel you confidence or the strength while solving the question of LCR series circuit. Next day we will also study the power factor. We have not studied the power of LCR series circuit as we have done for individual circuits, even LR and LCR, but here we have not studied the power. So average power we will calculate in next lecture, and then we will solve few numericals. Okay, my dear students. So this is all about today's lecture, my dear students. Thank you very much.